Hello everybody, welcome back to Anantha Lakshmi Academy. Today we are going to discuss the problematic part that is based on the introduction which has been already covered in the first video. So let me quickly revise what has been covered in the first part. So we have covered the trigonometric ratios based on the right angle triangle. So for a right angle triangle, here is the right angle, this is going to be the opposite side, and this is the adjacent side, and this is the hypotenuse. Let us name the triangle ABC. The angle between the opposite and adjacent side is the right angle. Here let us name the angle as theta, which is here. So based on this, we have figured out the trigonometric ratios as sine theta is opposite by hypotenuse, cos theta adjacent by hypotenuse, tan theta which is sin theta by cos theta opposite by adjacent, and the remaining three ratios are nothing but the multiplicative inverse, like cosecant theta is the multiplicative inverse of sin theta, which is 1 by sin theta, hypotenuse by opposite, secant theta which is a multiplicative inverse of cos theta, hypotenuse by adjacent, and the last one is cot theta which is a multiplicative inverse of tan theta, adjacent by opposite. So this is what we have covered in the introduction part. Let's get into the problematic part. Today we will be discussing the exercise 11.1. Where let's solve the problem 1 first. Yep. So let us look at the first problem. For the writing purpose, I have cut down the description part. So if you look at the problem question, in right angle triangle ABC, they have given the sides 8 centimeters, 15 centimeters, 7 centimeters as AB, BC, CA respectively. And they are asking us to find the sin A, cos A and tan A. This is the problem, the very first problem in exercise 11.1. So let's jump into the solution. So they have mentioned that the triangle ABC, in a right angle triangle ABC is what they have mentioned. So let us name the sides accordingly. ABC. AB is given as 8 centimeters, BC as 15 centimeters and CA as 17 centimeters. They are asking us to find sin A, cos A and tan A. Okay, now that we have revised all. Okay, so as per the revision what we have done so far, so how do we figure out sin theta? Sin theta is nothing but this one, the angle that has been made. Okay, sin A is nothing but sin theta. Alright, sin A is equal to, what is sin A? Opposite by hypotenuse. What is the opposite side? 15. And the hypotenuse is 70. So sin A is this. Then cos A. Cos A is nothing but adjacent by hypotenuse, which is equal to 8 by 17. And tan A is nothing but, you can figure it out directly from the formula, which is opposite by adjacent or sin A by cos A. Anyway, you will get the same answer. So opposite by adjacent is 15 by 8. Okay, let me draw that as well. Opposite by adjacent is nothing but 15 by 8. Or one more way of figuring out tan A is equal to sin A by cos A, which in turn gives 15 by 17 divided by 8 by 17. The denominator gets cancelled and the answer is 15 by 8. Alright, so here in a right angle triangle PQR, they said PQ is equal to 7 centimeters, PR is equal to 25 centimeters and angle Q is 90 degrees. Then they are asking us to figure out tan P minus tan R. So far we have discussed only one angle, which is theta. Wherever theta is placed, we used to call it as whatever the angle, name that is given, the letter, which is sin A. So here they are asking us to figure out tan P and tan R. So let's see how we could do that. They said a right angle triangle PQR Angle Q is 90 degrees. PQ is 7 centimeters. PR is 25 centimeters. And they haven't given QR. So tan P is what? Opposite by adjacent. In order to get to know tan P, we need to figure out the opposite side. So let's quickly do that. So given, first of all, write given. PQ is equal to 7, PR is equal to 25 centimeters. It is always good to write this given section so that you will know what is given and what needs to be figured out. Okay, PQ is 7, PR is 25. So how do we figure out QR? We have Pythagoras theorem. According to Pythagoras theorem, okay, what is that? PR square is equal to PQ square plus QR square. So QR square, what does QR square become? QR square is equal to PR square minus, I'm just sending this the opposite side, PQ square. Okay, this has come the opposite side. Now QR is equal to under root PR square minus PQ square. Alright, so what is QR? Under root of what is PR? PR is 25. And what is PQ? 7. Alright, QR is nothing but 25 into 25. 25 square is 625 minus 7 square is 49. So do the subtraction. 625 minus 49, 15 minus 9 is 6. And 11 minus 4 is what? Okay, 11 minus 4 is 7. Alright, 576. Okay, under root of 576. So can we get to know about this 576? Let's try 24 square. 24 into 24. 4 4 is 16. 4 2 is 8. 9. 2 4 is 8. 2 2 is 4. Okay, we are close. Perfect. Which is nothing but 24 square. QR is equal to 24. So we got the solution. QR is nothing but 24. Okay, here it makes, this is tan P. Alright, tan P is what? Tan P is nothing but opposite by adjacent. So tan P is opposite by adjacent. What is tan R? Tan R means angle is here. Alright, the angle is here. Okay, tan R is nothing but opposite by adjacent. For angle R, what is opposite? 7. What is adjacent? 24. So tan R is 7 by 24. Now, can you guys sort out tan P minus tan R? Yes, tan P minus tan R is nothing but 24 by 7 minus 7 by 24. Alright, that becomes 24 square minus, if you take the LCM, it will be 7 into 24. And when you cut down this thing, it becomes 7 square by 7 into 24. What is 7 4s are 28. 7 2s. This part you can simplify, right? 24 square is 576 minus 49. Minus 49 is 16 minus 9 is 7. This becomes 6. 527. Alright, 527 divided by 7 into 24. 7 4s are 28. 7 2s are 14 and 16. The answer is 527 by 168. So this is the simplification and all you guys can do. The new thing in this is tan R. everything in a trigonometry is associated with respect to angles. If tan r is here, you need to figure out the opposite side with respect to this angle and adjacent with respect to this angle. That will simplify the solution. So for the third problem, they have given that for a triangle ABC, it is right angled at B. Right angled at B, ABC. Okay, angle BAC is theta. Whenever they give the angle BAC, whatever is the letter that is in the center, that becomes theta. So here angle A is theta. Okay, so here they have given AB. So A is nothing but the side opposite to capital A. B is nothing but the side opposite to capital B. So here they have given us 24 and 25, and angle A is nothing but theta. They are asking us to figure out cos theta and tan theta. What is cos theta? Cos theta is nothing but adjacent by hypotenuse, which is nothing but small c by 25. But we don't know small c, right? We have Pythagoras theorem. As per Pythagoras theorem, according to Pythagoras theorem, so what is it? Can I say it as b square is equal to c square plus a square? The hypotenuse is b, the base is c, and the height is a. So this is b square is equal to c square plus a square. B is nothing but under root of c square plus a square. Right? So, but we have to figure out c. So instead of going like this, c square is equal to b square minus a square. C is nothing but under root of b square minus a square. What is b? B is given as 25. 25 square minus a square is 24 square. Just now we have figured out C is equal to 625 minus 24 square is 576. If we can do the subtraction, that becomes 625 minus. So the subtraction becomes 49, and 49 is nothing but 7 square. So our C becomes 7. What is C? Now this becomes C. So cos theta is equal to 7 by 25, and tan theta is equal to opposite by adjacent. If you want, you can write this as well, opposite by adjacent, which is nothing but 24 by 7. So that's the third problem. For the fourth problem, this is quite simple. Here they have given us cos A is 12 by 13. From this we can draw the diagram like this, A, B, C. Since this is cos A, let us assume here is theta. So cos A is nothing but adjacent by hypotenuse, right? Adjacent by hypotenuse. So from here, according to Pythagoras theorem, you can find out BC, right? BC is nothing but under root of AC square minus AB square. From here 13 square minus 12 square will give you BC, and that gives you sin A is nothing but, okay, let me, AC square is nothing but 13 square minus 12 square. 13 square is, I guess, 169. 13 multiplied by 13, right? Yeah, 169 minus 144, which is nothing but 21. This becomes under root 21. Nine minus 4 is 5. Okay, so this is under root of 25, and this becomes 5. So from here, sin A is equal to opposite by hypotenuse, which is 5 by 13, and tan A is equal to opposite by adjacent, which is equal to 12 by 13. So that is fourth problem. Here coming to the fifth problem, given 3 tan A is equal to 4. So tan A, what is tan A? Tan A is equal to 4 by 3. From here, A, B, C, tan A is nothing but opposite by adjacent. So from here, can we figure out AC? Yes, according to Pythagoras theorem. Here I am writing down in short forms. So this is quite simple. You can just write it accordingly to elongate your steps. So AC is equal to under root of AB square plus BC square, which is 3 square plus 4 square, 9 plus 16, 25, which in turn results as 5. Okay, so AC is equal to 5. So now that we have known this number, can we figure out sin A and cos A? Yes, sin A is nothing but opposite by hypotenuse. Cos A is nothing but 3 by 5. Here I am not writing it down. This is quite simple. You can do it on your own. Alright, let's jump into the next problem. So for the sixth problem, they have given that in triangle ABC and XYZ, angle A and angle X are acute such that cos A is equal to cos X. Then show that angle A is equal to angle X. So let us solve this. Let me write it as, let me draw two triangles ABC and XYZ. ABC, they have mentioned that ABC, this is an angle theta, this will be angle theta. Okay, they said that angle A and angle X are acute, which means they are less than 90 degrees, such that cos A is equal to cos X. Given first, cos A is equal to cos X. What is cos A? Cos A is nothing but adjacent by hypotenuse, which is AB by AC. And what is cos X? Cos X is nothing but adjacent by hypotenuse, XY by XZ. Alright, so if I take this downwards, how does it turn into AB by XY is equal to AC by XZ. Alright, so let us try figuring out BC by YZ, which is nothing but the opposites. Let's get down the ratios of the opposite sides. What are the opposite sides? BC by YZ. Alright, according to Pythagoras theorem, how does BC look like? BC is nothing but under root of AC square minus AB square. Okay, by YZ is nothing but under root of XZ square minus XY square. Okay, here if we assume cos A equal to cos X equal to some constant, since they have given that cos A equal to cos X equal to K, let us assume it here, which is nothing but AB by AC equal to XY by XZ equal to K. What does AB is equal to? AB is equal to, if I am sending it the opposite side, K into AC square, AC. And what does XY become? XY is equal to K into XZ. Alright, AB is equal to, since we have assumed it to be a constant, AB is equal to KAC, XY is equal to KXZ. Now let us substitute the same in here. AC square is equal to, what is AB? KAC whole square by XZ square minus what is XY? K into XZ. So that becomes, what is that? BC by YZ is equal to AC square and AC square are common. Here xz square and xz square are common. So I am taking them out. So this becomes AC square into 1 minus k square by xz square 1 minus k square. So let me take out AC by xz into under root of 1 minus k square and root of 1 minus k square. These two will get cancelled. Now BC by YZ is equal to AC by XZ, isn't it? BC by YZ is equal to AC by XZ. Here AC by XZ is nothing but AB by XY, which is nothing but the adjacent angle AB by XY. When the ratios of the sides of a triangle are equal, then the triangles are known as similar triangles. So for the similar triangles, angle A is equal to, for the similar triangles, the angles are also equal. They have mentioned that angle A and angle X are acute. So here we can say that triangle ABC is similar to triangle XYZ, since the sides of the ratios are equal, and hence angle A is equal to angle X. That's it. That's it for the sixth problem. Give me a recap of this. Given that there are two triangles ABC, XYZ, cos A is equal to cos X. For that, we have substituted them with the values, ratios, and we have assumed that to be equal to a constant K, and we have derived AB and XY. Apart from that, we also just took the denominators upside down here, such that AB by XY is equal to AC by XZ, just to show that the sides ratios are equal. Okay. Now, when we derived BC by YZ, this is the thing which we have not known. So BC by YZ, according to Pythagoras theorem, we have substituted the values. We have a constant multiplied with the sides. We just replaced it and they got cancelled, and finally we figured out that the sides ratios are equal and hence they are similar triangles. Since they are similar triangles, the angles are equal. So for the problem 7, they have given cot theta is equal to 7 by 8 and they are asking us to figure out, evaluate these things. Okay. Given that cot theta is equal to 7 by 8, what is cot theta? Adjacent by opposite, 7 and 8. So from Pythagoras theorem, can we figure out AC, which is nothing but under root of 7 square plus 8 square. So in order to evaluate this, once you figure out the hypotenuse, you can directly substitute your values of sine theta and cos theta over here. That is one way of doing. The same with the second one as well. If you just want to simplify this, the first one especially, because this is in the form of a plus b into a minus b, where a is 1 and b is sine theta. This is also a plus b into a minus b. A is 1 and b is cos theta. What does it become? A square minus b square is nothing but 1 square minus sine square theta by 1 square minus cos square theta. This is how it goes. Here also you can substitute, or you can just directly substitute in this formula. Alright, so this is quite simple, so I am not solving this. You can just solve it on your own. Right? So let us get into the problem number 8. So even for this, once you get to know the values of AC, sine theta is nothing but BC by AC, and cos theta is, you get right here from 7 by AC. So we can substitute it. Since this is quite simple, I am not solving this. You can do it on your own, right? Okay. So this is the 8th problem. In a right angle triangle ABC, right angle let be tan A is equal to root 3. Then figure out sin A cos C plus cos A sin C. If you see here, they are asking for two angles. Let us just solve this. So this is a right angle triangle. They said right angle let B. So let's name this as B, A, and then this is C. Okay, let me name this as theta. So they have given it as tan A is equal to, given tan A is equal to root 3. Tan A is nothing but what? opposite by adjacent. So since they haven't given any denominator, let us assume this as 1. So how do we figure out AC? AC is nothing but under root of AB square plus BC square. Alright, AB is nothing but 1 square plus BC square is nothing but root 3 whole square, which just turns into 1 plus 3 root 4, and AC is nothing but 2. AC is nothing but 2. So when we are looking from the perspective of A, sine A is nothing but, what is sine A? Opposite by adjacent, which is, opposite by hypotenuse, BC by AC, which is root 3 by 2. But cos C, what about cos C? For cos C, we need to look from here. Cos C is here. So for cos C, what is opposite to C? AB, right? And adjacent is BC. What is cos? Adjacent by hypotenuse. Adjacent is nothing but BC, and hypotenuse is nothing but AC. So what does that become? That is also root 3 by 2. Sin A is same as cos C. That's just a coincidence. What we need to remember is whenever the angle is changing, we just have to remember that sin is opposite by hypotenuse, cos is adjacent by hypotenuse. So if it is A, we will write from here. If it is C, we will write from here. It's just that whatever is the angle, you need to know for that, whatever is opposite and whatever adjacent. That is what we have to know. Okay. For this cos A is nothing but from here. Cos A is adjacent by hypotenuse, which is AB by AC, which is nothing but 1 by 2. Then sin C is sin C. For sin C, we have to look from here. For sin, this is opposite by hypotenuse, which is nothing but AB by AC, which is also 1 by 2. Now that we have evaluated sin A cos C and cos A sin C, you just have to substitute these values and simplify this equation. Alright, that we can do by here. The first problem, sin A cos C plus cos A sin C, sin C is equal to root 3 by 2 multiplied by root 3 by 2 plus 1 by 2, which in turn becomes 3 by 4 plus 1 by 4, which is nothing but 4 by 4, 1. Okay, this is problem number 8, first problem. The second problem is same as this. It's just a subtraction part. It's the same way. Now we have evaluated sin A cos C. You can evaluate that as well and simplify it by yourself. So this is what we have in exercise 11.1. So in 11.1, if you look at problem number 6, that is exactly the same as example 2 just before this exercise. That's the reason I have asked you guys to go through the exercises first, even before we jump onto the problems. Okay, so this is about exercise 11.1. In the next video, I'll be covering the trigonometric ratios for specific angles, which is sine 0, sine 30, sine 45 till 90 degrees. I'll be covering that theory conceptual part. Later on, we can go to the exercises. All right. During this pandemic time, it is very much recommended to stay at home and stay safe until and unless it is an emergency. Do not step out. So stay home and stay safe. Thank you. This is Anantha Lakshmi Academy. If you feel that the content is worth enough to listen, just like, share and subscribe this channel. Thank you.